Hello everyone, this is the part 2 of the video. In the previous lesson, I talked about what is bonding, and now I will explain in briefly what is ionic bonding, or you can say electrovalent bonding. So, what is ionic bonding actually? In the previous lesson, I told you that it is a transferring of electrons from one atom to another. I showed you with one example of NaCl. So, this I already told you that it's also known as electrovalent bonding, and uh, and I also told you this part that bond form it is a bond form between a metal and we talked about this point, and this point. So now we'll learn some more properties of ionic bonding, this and this. So, uh, for definition, you can write this one that ionic bonding is a transferring electrons, but you should know the properties that we cannot put bond between ionic bond, and the other main part is that the bond formed in ionic bonding it's mostly formed in solid because they have strong electrostatic force of attraction between ions, and a large amount of energy is required to break the bond. And this point I will explain in short points. Like this means that they are easily soluble in water because water is a polar compound. Here you can see that polar compounds are compounds that have slight charges within the compound. So uh, it's easily soluble in water because water is a polar compound. It decreases, I'm repeating, it decreases the force of attraction. It decreases the force of attraction, resulting in free ions. And it shows a fast speed of chemical reaction in aqueous solution because in aqueous solution, the ions dissolve easily and can pass electrons easily to one another. First of all, to know ionic bonding, you should know three main terms, which is first I will tell you the main ionization energy. Ionization energy is the amount of energy we need to remove electron. Like it's the amount of energy we need to remove electron. Like uh, suppose this is an element. Yes, element on this side of the period, on left hand side of the periodic table, will have less ionization energy than element on the right hand side. And this is one property of ionic compound. So it means that ionization energy should be less to make their bonds. To make bonds, ionization energy should be less. Did you get my point? Yeah, so, and the another main term is electron affinity. What does electron affinity means? Electron affinity is an energy that occurs as an atom. I mean that for ionic bond, electron affinity should be more because the tendency to take electron is more. Those elements which have more electron affinity can take the electron and form ionic bond. That means more Ea, I can write electron affinity as Ea, more electron affinity make ionic bond. Make ionic bond. So here also you can see that high affinity. The elements which are above on the periodic table, they have more electron affinity. Then as we go down the periodic table, the electron affinity decreases. You can write a point that as we go down the the periodic table, I mean electron affinity decreases. And likewise, you can write as we go up the periodic table, the electron affinity increases. You can write this point. I think I don't need to write it. So, and the third main point is electron negativity. So, what is electron negativity? Negativity, the elements which can keep shared pair of electron are electronegative. Like the elements which can keep shared pair of electron are electronegative. This means the difference of in ionic bond, the diff of I mean electronegativity, should be more. Should be more. This is main point. The difference of electronegativity should be more. So here you can write one point as ele electron negativity increase as we go from left side to the right side of the periodic table. And as we go from here to here, electronegativity is increasing. And from the so you can write as we go left to right of periodic table I mean electronegativity increases. And as we go from down to up, I think I don't need to write it. You can write it yourself. Or do I need? I think I don't need. You can make it. So now we will go back to ionic compounds. Here, ionic compounds. So the main points, like the main properties of ionic compounds are they're made of crystal, have high melting and high boiling. You should remember they have high or low. So first point what you should remember is they are made of crystal. Made of crystal. Sorry. They form crystal. I'm sorry. Here you can write. Here you can write they form crystal. And the second main point is that here you can write they uh, form crystals. Second is you should remember high MP, I mean melting points, and BP, I mean boiling points. They're often soluble in water. You know why they're soluble in water? Because they're ionic compounds. As I told you that in ionic bonding, they easily soluble in water because water is what? Water is polar compound. Water is polar compound. They conduct electricity when molten or dissolved in water when free ions, as you all know that in water free ions are present. So they conduct electricity in water when free ions are present. But not when solid. They don't conduct electricity when solid. So now we will move forward. Now I will show you some examples, like examples of ionic bonding. We learned one example in the previous lesson. It was about sodium chloride. I told you that sodium will give one electron to chlorine, then they will form sodium chloride. Likewise, here also we will take two examples. So we will take calcium oxide and magnesium chloride. First, I will tell you how to make calcium oxide. Calcium, you all know that calcium is 20. That means 2882. And oxygen is uh, 8. That means 2 and 6. So now calcium has two electron in its outermost shell, and oxygen has 1, 2, 3, 4, 5, and 6. So now if calcium will give these two, they will form CaO. I mean, they will form calcium oxide, so they will become stable. So that's all you should do. You know what is the main point? You should look at the outer shells, the outer orbits, the number, and then you should make, then you should make the outer orbits like this, and then you will see that here it needs two more electrons. So if it will give, then they will form CaO. Now it becomes stable. And for magnesium chloride, magnesium and chlorine. Magnesium has two electrons in its outermost shell because it's 2, 8, and 2. And this is 2, 8, and 7. So here it have 7, 1, 2, 3, 4, 5, 6, and 1 here, and for another one, 7. Now, you know why I draw 2? Because here it has two electrons, but here it needs only one, and here also, but it wants to give two, so it will give one here and one here, and they will form compound MgCl2, magnesium chloride. That means now it became stable. So I hope you guys understand what I did. And you know what you need to do? Just you need to pay attention on the outermost shell, outermost orbit, and the number of uh, electrons it contains. Then it will become easier. Then it will become easy for you. Now, so this was the end of the part one. Sorry, this was the end of the part two. We covered bonding, we covered ionic bonds and ionic compounds. We covered all these three things. And now in the next lesson, I will tell you, in the part one of this video, I told you about ionic bonding. Now in the third part, I will tell you brief information about covalent bond, and the condition and properties for it. Thank you. Hope you learned something from this video.